Okay, welcome. So let's start because the timer is started, so time is ticking. So welcome to my talk, Micronaut, Dragon Slayer of Spring Boot, or just another framework. I would like to thank you for choosing this talk. I know there's a lot of great talks happening at the same time, so thank you for choosing this one. First of all, let me introduce myself. My name is Vladimir Dejanovic. This is my Twitter, my mail, my GitHub account, my blog, if you want to contact me online. My day job is Senior Director of B2C Technology at PVH. For you who don't know about PVH, PVH is a fashion tech company, and we're a company behind the brands like Tommy Hilfiger and Calvin Klein. And if you like to know more, just ping me and contact me afterwards. Also, have a night job, so to say, like where I'm very busy, like with the jugs. I'm a founder and leader of Amsterdam Java user group, so that keeps me awake during the nights. Also, I'm speaker at conferences, like this one, of course, and I'm Java 1 Rockstar and Code 1 Star. But enough about me. So what are we going to talk about? What this talk is about? First, I'm going to actually share with you motivation for this talk. Like, actually, why should you care about something like a Micronaut or all those other kind of things? Then, majority of the code of the talk is going to be actually live code and live coding, and actually we're going to look at to compare Micronaut and the Spring Boot, how actually they compare one to another. There will be, of course, some time for questions at the end, and you probably all know that you should be going on slido.com, and basically there is like posting the questions, but this is like the third day of conference, so I hope that you already know that. Okay, so before we start, I want to share a few disclaimers with you. The first disclaimer is I love Spring and I love Spring Boot. I'm like heavy user of both of them, basically, and I use it for a long, long period of time. So if you expected that this talk is going to be like a rant talk while like Spring or Spring Boot is terrible, I'm sorry to disappoint you, this is not going to be talk like that. Another disclaimer is that I'm not involved in development of Spring or Spring Boot or any of their products or ecosystems in any way. So I'm basically just a user. The similar thing for the Micronaut. Again, I'm not involved in anything regarding the Micronaut, so I don't have a stake in any of these technologies. I'm basically the user in both of them. So in theory, I should be like, have independent view on both of them because I don't have a stake with them. Also, all things that I'm going to share with you are my own personal experience. So, for you, it might be different. So whatever I say, take with a grain of salt. Just, like verify it yourself. So, what is my motivation for this talk? If today, basically, we decide to build any kind of application or the web application or anything else, there are basically two approaches that we can do. First approach is we can go with the library and toolkit approach, or we can go with the frameworks. And if you want to go with the library and toolkits approach, Vertex is a very good example of basically of a toolkit for building reactive applications on the JVM. Another very good example is also Redpack, which is a set of libraries for building HTTP applications. On the other hand, if you want to go full framework approach, then of course there's Jakarta EE, or formerly Java EE. Of course there is a Spring, right? And like from recently there is also a Micronaut. But the biggest difference basically in choosing one of these two approaches is basically, okay, what you want to achieve. If you go with the library and toolkit approach, there's much more choices for you, much more freedom. You can do whatever you want to do. However, you need to basically make a lot of choices. You need to basically assemble all those kind of things and make sure that when you actually assemble all of them, you have a very good product. On the other side, if you go the framework approach, basically a lot of choices and decisions are already made for you by the people who actually develop the framework. They already tested, make sure that it works, and they have a vision how application should look like. And as long as you actually stay inside that basically vision of theirs, you're going to be in a perfect place. So when we as developers are basically, forced that we have to choose one or the other, majority of the people choose frameworks. And there's a good reason for that. Because we as developers are much more productive with the frameworks, because we can assemble something in a much faster way and just push it to production. I'm not saying that in the production it's going to be faster or better than like if you go with toolkits and libraries, but from developer productivity point of view, it's a faster choice. And better choice, so to say, for most people. Again, the biggest basically framework used out there is of course Spring and the Spring Boot. And that shouldn't come as a surprise to any of us, because let's be honest, Spring and Spring Boot is a really, really powerful dragon. with a lot of magic and a lot of power behind it. It actually does a lot of stuff for us. Ecosystem is huge. Whatever type of application that you want to build, there is something in the Spring and Spring Boot ecosystem to help you actually do it in a very fast and easy way. User base is also huge, so which means that basically if you're a company and you're hiring somebody, finding somebody who actually has this knowledge is not a problem, which means that you can actually maintain your application for a longer period of time. And like I said, I'm also a heavy user of a Spring and Spring Boot, and all the companies that I worked so far were also heavy users of them. However, all this power and magic, of course, doesn't come without its price. Because, let's be honest, nothing comes for free. So what are the prices that we have to pay? Well, if you think about how actually Spring works, it does a lot of basically things in a runtime. It does a lot of reflections, proxying, and all that kind of stuff, injections for you, which means that we have to pay price in memory, because all those objects have to live somewhere. Other thing, again, because all of those things are done in a runtime, it means that we have to pay with the CPU, because again, the CPU has to spin all and basically do a lot of stuff for us in a runtime. Another one is startup time. Again, during the startup time of your Spring application, Spring has to basically scan all your code base and everything, do all the injections, make sure that everything is good, and again, that takes time. Last but not the least is GraalVM. So I assume that everybody heard about GraalVM. At the moment, best to my knowledge, Spring doesn't work with the GraalVM. I know that people from Oracle and Spring and Pivotal are actually working very hard to make this happen, but as of today, basically as far as I know, it's still not possible. So the question is, okay, is there some framework out there which gets all the power and all the magic of a Spring and Spring Boot, but doesn't have to pay any of its prices? Well, if you ask some people, the people from the Micronaut, they would say, yeah, it's Micronaut. So I saw a lot of beautiful presentation by the Micronaut, and I was really impressed what I saw. However, all the presentations were done by people who were really heavily invested in the Micronaut. So of course they're going to show you all the shiny and nice things, right? Who's going to show you the demo of something which doesn't work? So that's why basically I said, okay, I want to see as a developer how it's differ one to another, how they compare. Is there huge difference? Is small difference? How it actually goes? So I set a very simple challenge actually, and challenge consists of this. I want to build a REST API because that's I think most common use case. Of course I want to connect to the database, because if I don't connect to the database, then what kind of REST API is that? I want to have a service from the code organization point of view, or something like that. Because I believe that if we have abilities to create services, then we can organize our code in a much nicer way. Also, I want to have template engine for HTML, so I want to have some way of actually hosting the static files, basically having some dynamic websites. If I want to basically host the whole application, front and back end, I can actually do it in some way. And of course, last but not the least is security, which always comes last. But again, I want to have security. So, Spring Boot solution is already online, so let's actually take a look at it. So, how actually we do nowadays if we want to do something with the Spring Boot? Well, we go to start.spring.io, right? We actually here put, okay, what's the package name, demo, actually artifact, and we put, okay, we want web. We want H2 for the database, H2, yes. Then we want to JPA, or we don't want JPA, or we want Lombok for actually to make it easier. We want security, and whatever you want to do there, you basically download the code, and then you actually start developing the code. So I don't want to spend time now downloading it because I already have it here. So when we actually open our application, we will have Spring Boot application starter, right? Which is just a main class, that's it. Then we will have a book controller. Basically we say, okay, it's REST controller. And then we say, okay, we inject some resource, in this case service. And we say, okay, want to say /books. Basically we will return all the books. Then when we go on /admin/book, in this case, I'm going to actually add the book. So I know I'm adding stuff with get. It's a terrible thing. Don't do this production. This is just a demo. If we open book service, we're going to see, okay, we just add annotation add service. That's it. So Spring does everything else for us. We again inject some resource here, and we have some methods like for getting all books and reading all books. So if we go and open book repository, again, Here, the Spring does almost everything for us. We just say, okay, annotation at repository, we have interface, book repository, which extends JPA repository for the type of book, ID long, and that's it. And if we open book, here I have a data from the Lombok. I can't see anybody, so I hope that you know about the Lombok. If you don't know, it's basically a very good library which generates a lot of getters, setters, boilerplate code for you. So if you don't know about it, look it up. It's very good. Then we add entity, and we have basically fields. Also, we have security. So basically here in security, I define basically just configuration, enabled web security. I have simple security Java config, which extends web security config adapter. And here, basically what I say is, okay, if anybody requests the /books, give it to everybody. If somebody actually wants to add a book in admin section, then that person needs to be authenticated. Also, here I have a time leaf, basically for login screen, just so that actually I can show, okay, I have it. And I have a simple config here, again configuration, which basically connects my URL login with the view login. And that's it. So that's the whole code. Oh yeah, by the way, in application properties, I already have set up H2 instance by default. So if we now go and basically build this code, let's first compile it and see how much actually how it goes. So on my machine, it took 11 seconds, roughly. So let's try to remember this thing. Now, basically, if we start it, and we start this application, and I started it as a Java jar because I want to actually compare it later with the Micronaut. So let's see how long it actually takes to start. So it started in 17 seconds, and somewhere above I should get, well, this is going to be fun. Okay, so this is the password. Okay, so I need to remember this one. So, okay, I remember that one. So if I go now here, let's say localhost 8080/books, if I know how to type, basically I get nothing because I don't have, because there's nothing there. And if I say, okay, like I want to add something, let's say admin/book title 1Q84, why not? I should be asked, okay, like you need to log in. So I provide user, I provide the password, which I already had. I sign in, and basically I added one book, so I can add one more. Let's say dance, dance, dance. And now if we basically go and ask for the books, voila, we have 2 books. So let's kill this. So it works. Okay, so let's now look at the Micronaut. So again, the full solution is also online, but we're actually going to live code it now. Fingers crossed, everything goes good. So the first difference basically between the Micronaut and the Spring Boot is that there is not start.spring.io. So that website doesn't exist when it comes to Micronaut. So first thing that you actually need to do is go and install SDKman. Once you install SDKman, then you can install Micronaut. And to do that, you just say SDK, and basically there's like a list. And there somewhere should be like Micronaut. Yeah, so there's, okay, so here's a Micronaut. So we need to install sdk.install.micronaut. I will not install it, of course, because I have it. And then we say SDK list Micronaut, and you can see all the different versions, basically, which are out there, which so I have like 1.0.4, and that's it. Once we install Micronaut, then we can actually do this. We can say mn, and then here's like a CLI, basically helper for the Micronaut, where you can do all kind of stuff. So we can say help, and we see all kind of commands, and we can see list profiles. There's like different profiles here, and we can say profile info service. And here are all the services. Oh, this is like too big, maybe. So these are all the profiles that you can already have by default. So this is like the things that we were adding in a Spring Boot. You know, like when we had the like Lombok, time leaf, all these kind of things. So basically, this all the things already there present in the Micronaut, and you can just add them. So how we actually then create application? Well, we can just exit this for now. We can say create app, and then we can say app name. So I want Micronaut. If I press enter now, it will create empty project, basically by this name. But it's going to use Gradle. And if you want to use Maven, then you just need to say ---- build Maven. Then you can also say features, hibernate JPI, and is it security session or session security? I always forget. Security session. Security session. And hopefully, if I didn't do any typos, it's going to create me a new project. Okay, so we have a project. So let's open it in IntelliJ. Actually, first I want to copy book because I'm going to need a book because I'm building exactly the same application as I have now. So let's say open Micronaut. Yes, open POM. Come on. I need a mouse. Definitely. Opens the project. Yeah, this window, why not? Who cares? Okay, so just give it a few seconds to actually scan the whole project and everything. Okay, so let's go to presentation mode. So, few things that I want to do. First thing that I want to do is I want to delete all the tests. Because we all love tests, right? No, I'm joking. I'm going to delete them because I don't want for that part to have any influence on my, comparison to the Spring Boot. So that's why it was easy to just delete them and that's it. The second thing, I want to actually rename this package. Refactor, rename, to something which I like more. Shark. So okay, so we refactor it. Cool. So now we don't need this package anymore. Yes, enable auto imports, please. So we don't need this one anymore. Let's delete this one. So let's look actually what we have by default. So by default, we have only one class, which is basically application main class Micronaut run. So almost exactly the same like a Spring Boot. Then we have basically some resources. In resources, we already have logback already set up for us. And in application, we have like, okay, application name. We have database here already set up. And we have a security, which we are going to comment for now, because we don't need it at the moment. And that's it. So let's now actually start adding the stuff. So first, I'm going to add a package, Pojo, and I'm going to add the new class, draw class book, because we're building, like I said, exactly the same application like last time. Okay, copy paste, yes, import. So one thing that actually now I'm not going to use is Lombok. The reason for that is because Lombok actually works in a way that during the compile time it generates all the boilerplate code for you. Micronaut actually does exactly the same thing. So that's why actually why they say, okay, this has all the power of the Spring, but but none of the costs. Because all the things that Spring does in a runtime, Micronaut does in compile time. So Lombok and Micronaut sometimes clash with one another. So you can make them work, but for this demo I just said like, yeah, I don't need that much. I just need like one class, so it's not that big of a deal. So I'm going to generate getters and setters for both classes, and basically that's it. For what I needed from the Lombok actually, so that's it. Okay, so now next thing, of course I need somehow to connect to the database, right? So let's create repository. And let's create book repository. Book repository, yeah. Okay. So in case of the Micronaut, we don't have a repository thingy, but we have Singleton. Singleton, yes. Come on. Oh, yes, yes, Singleton, yes. You see, I need to know how to type. Then we need to add persistent context, entity manager, come on, entity manager, yes. Let's go private, final, application configuration, yes, application configuration. So now we have dependencies, and now we actually need to inject them. And there are multiple ways how you can actually do that in the Micronaut. The default way is through the constructor. So you just say public book repository, yes. Oops. Current session, yes. Entity manager, application configuration, yes. And then we say this dot entity manager is entity manager. This dot application configuration is application configuration, and that's it. So now we need to basically say public list. We want to actually have like find all, something like that, for book. Get find all. Let's call it find all. Find all with two L's. Come on. So let's import the book. It actually knows what it needs to do. Of course, we also need to import list. So also I'm going to add here transactional from the Micronaut. So because make sure that you add transactional from the Micronaut, we say read only is equal true because this only reads data. So let's create a string. SQL query is select O from come on book as O. Query is equal entity manager. Create query, SQL query, yes, for book.class. Then let's create this variable. Okay, and then we say return query get result list. That's it. If I didn't do any typos, hopefully not. Let's add another transactional, and then basically say like public for saving, because we also need to add the book, right? Book save. Yeah, why not? Let's just call it string title. Yeah, why not? String title, basically say book is new book. Okay, let me just see, so that you can see it better. Book. By the way, do I go too fast or not? It's okay? Okay, if I'm at any point start going very fast, yell at me. Okay, book, set title. Okay, book, what? Oh, thanks. See, this is a good thing. We all work together. Book set title is title. Then we say entity manager, persist, book, and then we say return book. And that's it. So, repository done. Now let's actually add the service. So again, the same thing, we create a new package. Where's the package? Yes, package. No. I really need to have a mouse. New package, service. Again, let's add book service. Book service, okay. Again, the same thing. We don't have a service, we just add Singleton. And that's it. Then we add private book repository. Again, the same thing, we add it through the constructor. Book service. Book repository, okay. Book repository is book repository, cool. And then we actually need to say, okay, like a public list, come on, book, find all, or whatever. We say just return book repository, find all. or let's call it find all books. So we're like fancy. Import class, import this class, public book, add book, string, title, and then we say here return book repository, save title. That's it. Done. Service done. Now we need to go and do controller. Come on. New package controller. And now here we need to add book controller. Book controller. So in this case, we will add controller annotation. So that one exists. Again, the same thing. We need to inject service, book service, book service. Again, we do it through the constructor, book controller, book service. Yes, book service. This dot book service is book service. So that one is done. Then we said, okay, we have get basically on the path slash books. Public list book get all, who cares, return book service, find all books. Yes, that's it. Let's now import this. So this one is done, and now another one get. So it was slash admin slash book, if my memory serves me right. Public book, add book, query value, and we can add here title, string title, and then we say return book service, add book title. So this should be that. Let's actually now try and compile it. Again, this is not complete solution, right? We're still missing the security, we're still missing like the templates, but this is like almost done. Why not? Okay, so look this. One thing that you need to look into account. It's compiled in 18 seconds. Spring Boot, full solution, 11 point something seconds. Again, this shouldn't come as a surprise because, like I said, all the things that Spring Boot and Spring does on the runtime, Micronaut does in compile time. Okay, so bookstore. So let's now actually start it. Let's see how it's going to start. And again, let's look in how much time it actually starts. So it started in 4 seconds. So much, much, much faster than the Spring Boot. But yet, of course, this is still not a complete solution. So let's actually check, does it work? So if we go to the same URL, okay, so localhost slash books, we should get nothing. Oops. Okay, so I did some wrong. Okay, so now it's going to be fun. No type of graphics entity manager exists. Using to make sure. Okay, so I haven't seen this error so far. It's going to be fun, right? Create beans. Okay, let's go quickly through the code. So, okay, so book service. Okay, book service. So this one should be correct. If we go to repository, entity manager, current session. Yeah, but it should be Singleton. Yeah, that should be that one. Recent contents. Entity manager, application configuration, current session. Let's see, what was the error? Create bean. Unknown source control. Okay. Entity manager exists, ensure that the class must be no bin of type. Entity manager, come on. So it's complaining about book service. Okay, in book service, what we have? Private book repository, and it's Singleton, and book repository, resistant, okay, so Singleton, resistant context. Okay, this is funny because all should be good. Current session, transaction, Singleton.
I don't know if it doesn't matter, but packages are created not in this one package that you created, but in default package. So you have much more structure in package.
Okay, I'm not following you, but okay, let's try to do something else. So basically, I have a backup.
Open the packages. Check the packages on the class.
What, on target? You mean here?
All packages are in Java directory directly.
Yes.
And I don't know if it happens.
Oh, that's a good thing, yeah. Where's my package left? Where's my application also? Okay, application is here, so, oh yeah. So you need to go here, refactor. Yeah, that's cool, that's good call, yeah. Okay, then you need to go here. Oh, see, like, this is the first time I did this, something like this. Thanks, good catch. Okay, so now, fingers crossed, all works, right? The good thing is, okay, I have 18 minutes more. We should be good. Like I always say, you know, live coding is always interesting. Like, if everything works, perfect. If something goes wrong, great for you, terrible for me. Yeah, but good catch. So let's start it now. The good thing is, at least starting is very fast. Compiling is not really, but starting is the fast part. Maybe not. Okay, 7 seconds. Okay, it's not that slow. So slash books. We have nothing, of course, because we don't have anything. If we add something, admin book title, we add one, of course. Let's say some other. We definitely don't have this one, right? So if we go books, voila, it works. So let's now add actually security. In order to add security, first thing first, I need to go basically back to application, property file, and uncomment this one. So that's the first thing. The second thing is I need to add a configuration. So let's add package at a good place now. And let's add simple authentication provider. Provider, okay, go away. We add Singleton. We implement authentication provider. Let's implement the method. Yes, I want to implement this method. And now I say if authentication provider get identity dot equals user, and not here. And authentication provider get secret equals very complex password. Then return flowable just new user details. For user. And here we just say new array list. That's it. Come on, import it. Else, we just return flowable dot just new authentication failed. Yes, that's it. So now another thing that I need to do is actually I need to create views. So I need to add the templates. So I'll here create directory views. So I'm not going to code this part here because I'm going to lose a lot of time. So I'm just going to copy it. So I'm going to copy it from my backup. Backup it's home and it's in source, main resources, views. Then I'm going to copy from my backup login. So it's login. No, it's come on. Out. Okay, out. Source main resources views. And I'm also going to copy login controller. Login controller, and I'm going to add source main Java, okay, controller, and I'm going to also do the same thing for home controller. I'm going to show you the code, but it's not very interesting, so that's why I didn't actually want to code it. So basically what I did is I added two controllers. The home controller, which actually is, oh yeah, I forgot, also I need to add the dependencies. You see, that's a good thing when you open the code. So I need to open, where's my POM? Here's my POM. I need to add two dependencies. The first dependency is Micronaut views. So that's the first thing, Micronaut views. The second dependency is I need to add the time leaf. Because again, like without the time leaf, like I'm not going to be able to use it. Yes, version 3.1. So I added Micronaut views, I added time leaf as a template engine. Basically then I added controller, which actually, creates a controller, and basically on home actually connects to my view home, which is here very simple template written in time leaf. The similar thing I do with the login, which it's here, and it also has, if I log in, if I fail to log in, what happens? Also let me update this here, login slash this one. And last but not the least, now I need to also make sure that my book controller is basically secured. So what I'm going to do here, if you remember, I'm going to say secured. In the case, security rule, in case of books, I want to give it to everybody. So it's going to be security rules is anonymous. And in the case of admin book, I'm going to say, you just need to basically be logged in, authenticated. So this is one way how you actually can add security. You can add security through the properties files. You can add it through using different annotations. You can use basically JSR for security. So all kind of different ways how you can actually add security. So let's now compile the full solution. Let me just show, I'm in the right place. And let's see how much time it actually now needs to compile. Again, my guess is going to take more time than the Spring Boot, because it actually needed more time when it wasn't full solution, and now is a full solution. Again, in case I didn't do any hiccups in the coding. So it took 19, almost 20 seconds. So if I want now to start it, let's see how it's going to look. Is it still going to be faster than the Spring Boot? Spring Boot was, what, 17 seconds, something like that, right? So again, it started 7-ish seconds, so it's still extremely very fast. Okay, but let's see, does it still work? So if I go /books, I shouldn't see anything because we restarted the application. Of course, there is nothing. So now if I say admin, book, and let's say add title, it asks me, I need to log in. So you see, templating works. It's like beautiful CSS. Okay, so add user, password, login. Okay, so we're logged in. So let's now actually try to add some different. So basically, so I managed to add one after dark. I added the second one, and if we go back to the books, we have both of them. So all works. Good. So like I said, both full solutions are online, so you can just compare them, look into them. Again, they're not very complex, but I think that they covered the majority of the things that basically we do use in day-to-day work. Okay, so these are going to be now results on my machine. On my machine, like I'm using Java 11, I'm using Maven 3.5 something. I haven't touch any Java flags, memory sizes, anything. Like, as I showed you guys, basically that's how I run it, and basically took some tests. So I just, of course, like run it, do some like load testing, very simple, but in both cases the same. And then just want to compare the numbers. Of course, if you tweak a Java virtual machine, everything, you will get different results. So build time is, for me, usually with Spring was around 10 seconds. Micronaut was around 21 seconds. Again, when you think about it, okay, what amount of work Micronaut needs to do, it doesn't come as a surprise. It does a lot of things for us during the compile time. Okay, startup time. Well, Spring started roughly around 15 seconds. Micronaut basically started around 7.1 seconds. So it's like twice as fast, at least in this example. Which I would say then, Micronaut wins. And again, this shouldn't come as a surprise, because Spring does a lot of us during the runtime, in the startup time, while Micronaut doesn't. Okay, how about the memory? Well, again, without any flags, any tweaking, anything, Spring Boot took around 190 megabytes. Micronaut 80 megabytes, which is a much, much, much less. So again, I would say Micronaut wins. Okay, so now we come to CPU. Well, this is kind of tricky. So this is how Spring Boot application looked like in Visual VM after some load. And this is how Micronaut looked in Visual VM after the same load. So my conclusion is like, yeah. Actually, I would say like my example is like not very good fun to actually see how it performs with the CPU and like is it good or bad and all those kind of things. Again, it's a very simple example. However, from all the things that I know, how actually Spring works and all the things inside the Spring and how actually Micronaut works, I would still say that my assumption would be that the Micronaut would win. But again, I don't have a proof. Now the big one, the Graal VM. Well, I'm going to say this also, I didn't demonstrate it that Micronaut wins. And the reason for that is very simple. I saw a lot of demos of Micronaut with Graal VM. And if you go online and Google it, you will find a lot of them. Like I said, as far as I know, Spring doesn't work on a Graal VM yet. I know that Pivotal and Spring guys and basically Oracle are working very hard to make it happen. But as far as I know, until today, it's still not possible. So wins goes to Micronaut. But now actually the big one. Okay, how actually I would score my challenge? So the challenge was simple, was naive, but again, it covered, I would say, majority of the things that we use in day-to-day work. So I would say that both of them were great. Both of them were very productive, very easy to actually develop. I did everything that I needed to do without any kind of problems. However, I would say that Spring was just better. Tiny better, and the only reason why is because of Spring data. Because in case of the Micronaut, actually I needed to create something like this. While in case of Spring Boot, I just added repository, basically one interface, basically extends other interface, done. Spring does everything for me. So that's the only reason why I would say that at this point, the Spring Boot just was very, very tiny ahead. However, I also know that the Micronaut guys are working very hard to actually eliminate this part also. Okay, where am I? Okay, so what would be my conclusion, to you guys? Should you actually, if you have some application, should you completely throw it away and rewrite it in the Micronaut nowadays? Well, my answer to that is very simple, and I would say definitely no. Keep your current code base, whatever it is, as it is. Because if you think about it, you will have to actually invest a lot of time and effort and energy into rewriting your application in a new framework to, in the end result, you get the same product, unless, and basically the question is how much actually you're going to gain in it. If you see, in my use case, I'm going to gain massively due to startup times, memory, or any other things, or Graal VM, then then you have a use case to actually go and do it for you. Otherwise, it's just wasting resources. However, if we're talking about the new project, then I would say definitely look into the Micronaut. It is extremely, extremely serious contendant. I looked into basically the documentation and it blew me away. I looked in tutorials, they blew me away. They're like, majority of it is like ridiculously good. Amount of stuff, which is now, today, actually exists in Micronaut, is like something that I couldn't imagine. So you have basically everything. You have like service discovery, you have basically Kafka, you have messaging, you have Cassandra, you have GraphQL, you have gRPC, like the list goes on and on and on. Basically what the Micronaut guys did is not only that they actually developed all kinds of stuff, documented it greatly, and actually it's in a very useful and easy way to actually pick it up, but they also looked, okay, what majority of people are using? Okay, they're using this, we covered that, and then basically we go to something which is less used, less used, less used, less used, and basically just starting actually expanding their ecosystem. It is fair to say, ecosystem for a Micronaut is not as huge as it is for Spring and Spring Boot, let's be honest. But again, it's getting a lot of speed and momentum, and it's growing very fast. And all the things that I saw so far from the Micronaut, like really, like, I couldn't believe it. Because usually, whenever there is something which is like very beautiful, there is some very, very dark secret somewhere behind, like, you know, in the corner, like, that you shouldn't find out. I haven't seen anything like that for a Micronaut. So for any kind of new project, I really recommend like look into Micronaut and like think about using it. Thank you. So this slide with the references, I hope that you put all the time, basically, I'll just leave it here for you if you want to take a picture. Then we go to the sliders, right? So everybody took a picture?
It's okay.
Okay, we can go. Yeah, it's going to be online anyway. So let's go to the Slidos. Okay. Does Micronaut support Kotlin? Yes. Done. Is it good to have alternative framework, but with all annotations and boilerplate? It looks like a bit going back to the JEE times. Okay. So when it comes to annotations, it's kind of a lot of basic annotations are coming directly from the Java and JSR. And again, like I use like custom ones for security, but you can use directly from JSR from the Java. Micronaut team, again, like Singleton is coming from the Java. So a lot of things are already coming from the, again, like yeah, it's true, from JAE world. But again, that's not, in my mind, that's not really a bad thing. So they tried really not to create annotations where not needed. And even if they really created some annotations, custom annotations for Micronaut, they always try to actually choose, like the name which is very logical. So like controller and things like that. So from my point, I think that their approach is very good. But again, like it's only my opinion. Like, why is Singleton required? Are these objects true singletons? Like I said, yeah, Singleton is required because they are true singletons. And if you look at basically Spring Boot, and you look like service, controller, and all those kind of things, they're also singletons basically, and Spring makes sure that they are singletons. So in this case, they didn't want to go, at least that's my interpretation, I might be wrong, that they want to go and create a ridiculous amount of annotations. So they say, okay, like we just use singleton, and that's it. And then dependency injections, okay, I want to take this one. Does Micronaut fully support Java 11? That's a good question. To be honest with you, I'm not sure. So my machine is running on a Java 11. So this is Java 11, but however, if I think that in my POM is target POM, where is it? Okay, JDK. So yeah, it looked like yes. So I didn't look at it. Let's be honest. How big is the Micronaut dev community nowadays? I don't know the answer to this. I know that there's like one huge company actually working behind it. I forgot the name. If you just search basically for the Micronaut talks, majority of the people who give the talks work for that company. But again, like what I know is that Micronaut is very, very fresh. Basically, I heard first time of it at last year Oracle Code 1, so I didn't even know about Micronaut before then. And I know before that, basically around that time, it was also like Micronaut first version 1.0 for production ready. So at this moment, I don't think that the Micronaut community is huge, but I think that it's really gaining a speed and it's getting bigger and bigger every day. But how big, I don't know. What HTTP server is Micronaut running on? As far as I know, it runs on Netty. So because like Micronaut is by default reactive and async, so I think the default one is Netty. I'm not sure how easy or difficult it is to actually add some other stuff inside. Isn't it risky considering support for ground VM a top thing while it is still well, I'm not sure if you know, but I think like I will lie to you. Like 2 or 3 days ago, basically Oracle came out with the Graal VM and said, okay, like, this is the first version which is production ready, and we're going to support it. So it's officially now that basically they say, okay, like, hey, this version, production ready, you can use it, we have support, we have licenses, we have everything, so go for it. So that's not the case anymore. Okay, considering machines are cheap nowadays, is it really worth in any production environment that are not lambdas? What I know also that you can actually also run, again, like I did this use case with the Micronaut, because in my case, that's the most common use case for people in Java. And by the way, I'm out of the time. But you can also run Micronaut with the serverless. So you can also do the serverless with the Micronaut, so you can also do that stuff. I'm out of time, so.
Still one question.
Okay. Do you really think there are so many developers that do know Spring? Really? You never met one?
I'm working with since Spring 2 with Spring project. Never met the only authors of Spring, more or less know a little bit.
Okay, but what's your definition of knowing? Knowing every single thing, or build a lot of applications with it?
So you put any bin and you know what's happening.
Okay, like my experience is like, you know, like I go to the conference, I throw a rock and I hit a Spring developer.
No.
That's my experience, at least so far.
I did a check yesterday on the table. No one.
Okay. Like I said, take everything which I say as with a Spring of salt. It doesn't mean that it's like that was my experience. But again, like I worked mostly with the companies developing Spring, and I moved from company to company, and every time it was Spring, Java. That was it. Okay. Thank you very much.